Well, hi there, everyone. We're going to start this video with a little cup of coffee. Notice that the formula for monthly payment on a loan has been written this way by Delta Math. Wow, that looks like nothing we've seen before. Wow. Well, but you're skilled at rearranging formulas, so you won't be fooled by that. Here is, and I've changed the names of certain letters for the sake of familiarity, okay? Um, if we remember that R over C is equal to I, and C times T is equal to N, okay? So C is the compounding period, and if I divide the annual interest rate, which I call little r, divided by the compounding period, I get the interest rate per period. That's that there. And then C times T, this is number of compounding periods per year times number of years. That will give you the total number of compounding periods. So I can already rewrite this a little bit, where monthly payment on a loan will be equal to the principal borrowed, or the amount, like the present value is another way of talking about that, multiplied by I, divided by 1 minus 1 plus I, as a decimal, of course, to the negative CT. Okay? And I've changed some letters from the note that we had, where I called it regular payment. Let's circle regular payment and present value. It's the same formula. Okay, it's just different letters for the same thing. Now, this was the formula here that Delta Math just gave. And it looks different from that, but it's identical. And let's see why. Let's multiply this formula here that we're working with, top and bottom, by 1 plus I to the n. Oops, I should have changed CT there to the whole idea was to get the letters to match up. So that's the negative n. Okay. And now we're going to multiply that top and bottom. That doesn't, we know that multiplying something by the top and the bottom, same thing, doesn't change that thing because that's just a way of multiplying by 1. So P times I times 1 plus I to the n. What will that give us as the numerator? Well, that will be the principal borrowed multiplied by the interest rate per compounding period multiplied by the growth factor, which is 1 plus that interest rate raised to the power number of compounding periods. That's the numerator. That's the result of this multiplication. Now let's multiply the bottom. But to do that, let's remember that we have to put that in brackets, and this distributes. That gets multiplied, and that gets multiplied, both terms. Okay, so 1 times something is just the something. So that will be 1 plus I to the n. And then minus this thing times that thing. So let's just write that over here. 1 plus I to the negative n multiplied by 1 plus I to the n. When you're multiplying things with the same base, you can add the exponents together. N plus negative n is 0. So this is equal to 1 plus I to the 0. What's something to the 0? It's 1. So this will be minus 1 because it's minus there. Okay, so that's what the monthly payment is equal to. Oh, it's the same. It's the same. So work with the one you like. Okay, it doesn't matter which one you use. It's like saying, should I box with my right hand forward or my left hand forward? Well, people have been successful doing it both ways. There's not a right and not a wrong. Do it your way. I'm going to do it my way, and then you're probably going to copy my way, which is just fine. Okay, let's take a look. The formula I have in Desmos Formas. There I have the formula that I taught you, but instead of R over C, I'm using I here because sometimes it gives me I. Okay, so we have here a monthly interest rate of 0.4. So I'm going to put that in for I. Okay, 0.004, that's 0.4% as a decimal. Move the decimal place twice. And then we know that the loan total value is $360,000. That in there. And then we want to do that over 15 years. So to find 15 years, well, I'm going to do this on a calculator to just show you. You got to do 12 months per year times 15 years is 180 months that it's going to take you to pay this back. So you're going to pay this back in 180 payments. So put that in for your N. To the nearest dollar, well, I have to round away 49 cents. How kind that is of the bank to forgive me those 49 cents 180 times. That's like them giving you $90. So 2809 is the answer. Yay! So that's how you can find the monthly payment on a loan. You can do it all in Desmos, or you can work it out by hand on a piece of paper each time. You do you. Bye for now, everyone.